we have Megan Collins speaking. She's an education program manager at the Desert Research Institute in Nevada. And in that job, she collaborates with scientists whose work, multidisciplinary work, relates to the environment and translational research to the stakeholders. She also builds programs to involve people directly in research, such as internship programs and community science, citizen science. So that's what, that part of it is what she'll talk about today. But what the most important thing is that Megan is a lifelong Chautauquan. So there should be some friends out there who know her, and we hope that you'll be kind to her. So today, Megan Collins speaking about creating community with science.
Thank you, Bob. Yeah, thank you for that wonderful introduction. I am so happy to be here. I'm so happy to see all these familiar faces. And as I was just saying, really excited that my work world, my professional world, and my Chautauqua world get to collide for this brief moment in time. As Bob mentioned, the topic of the talk today is citizen science, anti-science, and building community with science. I wanted to see how many times I could fit that same word into one short phrase to make sure you knew that I was talking about science. So if I were to give the whole talk in 30 seconds, this is what I would say. Science is sometimes seen as a process that is distant from everyday life and everyday people. And this matters because the well-being of our society depends on evidence-based decisions. But we can't build trust with more science alone. So we need to build tools and better tools to bring more people into science, and community science is one way to do that. And I'll elaborate on what that is and what it looks like in the Western US where I live. Since we have more than 30 seconds, I get to introduce myself and unpack some of those ideas a little bit more. As Bob said, I am a lifelong Chautauquan. I'm also a Western New Yorker. I grew up in the region. I am a Nevadan, which means that I live in Nevada, not Nevada. And so I live in the northern part in Reno. And I work at the Desert Research Institute, which is affiliated with our public university system there in the state. So we're kind of sisters with the university. And what we do, we're a non-degree granting institution. So our faculty do all the things that professors do when they're not teaching. So they do research, they write grants, they do advise some students, but again, we're non-degree granting. And I work alongside them to look for ways to, as Bob said, translate the research to stakeholders, or involve people in the work. So I develop internship programs, and as we'll talk about, citizen science. Before I go any further, I want to acknowledge that we are on the ancestral homelands of the Haudenosaunee, and I want to thank them for their past and present stewardship. So science is often seen as distant from everyday people and everyday life. And individuals in jobs like mine care about this because we're tasked with building bridges between science and society. And you may or may not know that within the field of science communication research, there's a whole area of study dedicated to public perceptions of scientists. So how people see scientists. Things like, they look at things like trust in scientists, or perceptions of scientist credibility, or even perceptions of benevolence of science. So it's all this like squishy stuff mashed together with this hard stuff. And it's really interesting for me because I can't do my work without understanding how people view scientists to be able to foster really strong connections. So I'm curious, just by show of hands, if you were to venture a guess, do you think that confidence in scientific leaders over the last 40 years has increased, decreased, or stayed the same? So if you think it's increased, raise your hand. Okay, 2, yes, positive. 3, optimists. 4, okay, decreased. Some, yeah, okay. And then stayed the same. Anyone think it's, okay, very good. So this tiny infograph, I'll explain, we'll go by the colors here. Was put together So this is from the National Opinion Research Center at the University of Chicago. They have 40 years of data from the General Social Survey, and this infographic is lifted directly from them. And they've got confidence in leaders. So the light blue is the military. The orange, which is what we care about, is the scientific community. So that's that darker color orange. We also have federal institutions in green, press in purple, and yellow in Congress. And what you'll notice is that of all of those different groups, actually scientific leaders is the one that's staying relatively stable. But anti-science movements or distrust in science is getting a lot more press these days. And that's because in smaller circles that are getting louder and louder, there is distrust in science. So we do care about it, but I just want to start on a fairly positive note that the world is not ending and people still do trust scientists mostly. So that's the key point there. And we'll talk a little bit more about those, like I said, patchy or heterogeneous pockets of distrust in science. So like I said, for my job, it's really important to understand how people perceive scientists. And in addition to citizen science programs, I run a talk series. I run trainings for scientists on science communication. And so I end up doing a lot of coaching of scientists on like how to connect better with their audiences, how to make their work relevant. And I often end up kind of working around some of these themes that I've got here. If you can't see, I'll end up coaching them on things like not ignoring human experience and emotion, not assuming ignorance in others, not being too critical or negating or wet blankets. And mostly this process is like just kind of unlearning a few things they learned in grad school because everybody is human. And so everything you need to know about science communication, you learned in kindergarten. So anyway, the point is that working closely with scientists works really well. We often have a lot of warm fuzzies after our events. But still, even if you have scientists that are really connected and well-trained to connect with their audiences, it still leaves us with this big problem of science and society on a meta scale, which is like the well-being of our society depends on evidence-based decisions in government, in business, in medicine, and in people's lives, right? And so we can't broach this topic without thinking about anti-science movements, which you'll notice the title of this slide is Anti-Science Beliefs and Attitudes. So just remember that, beliefs and attitudes, not information, not rationale, right? And you won't be surprised to hear that science communication researchers also study this, right? They study anti-science beliefs and attitudes, and they've given a name to some of the really, really polarizing dialogue or rhetoric around anti-science. They call it pernicious polarization. And a few examples, which I'm sure won't be the first time you're thinking about these or considering these, but things like anti-vaccine movements, constant questioning of public health measures like masks, and of course, climate change denial. So researchers have found that anti-science beliefs and attitudes correlate with factors like political ideology, religious affiliation, geographic region, educational attainment, and demographics. So they correlate with a number of demographic things. Quick poll. So this slide says, if you can't see it, I want to know if you agree or disagree with this. The slide says, a more productive approach would be for the anti-science public to embrace this lack of understanding as a motivation to learn more about science. Do you agree with this statement? Raise your hand. Do you disagree with this statement that it would be a more productive approach to put it on the anti-science people? So this statement is basically saying, if somebody's anti-science, it's on them to learn more, and learning more is going to change their mind. Okay, I'm getting some skepticism. Yes, good. Remember how I said that anti-science beliefs correlate with factors like political ideology, religious affiliation, all of that stuff. Relatively few of those things have to do with one's level of science literacy or the amount of information a person has, right? So we can't really fight anti-science with science, basically. That's what we can learn from this whole story. Another realm of science communication research has to do with how scientists view the audiences that they want to connect with. So before we were talking about public perceptions of scientists. Well, science communication researchers also study scientists' perceptions of the public. And this area of study, while it sounds kind of obtuse and like, how is that even important? Well, they've made one big contribution, and that is something called the information deficit model. So we can't talk science without having lots of jargon. I will unpack this for you. The information deficit model encapsulates a set of assumptions that scientists sometimes have, assumptions and a perspective on how to communicate with people, with the rest of us, right? So it assumes that science literacy, or the amount of knowledge a person has, is the main driver in people's perceptions and decisions to use science. So again, remember that evidence-based decision-making we were talking about? So it assumes that someone's level of information or level of knowledge is what drives their behavior using science. That's one assumption. Another is that it assumes that most of the public is scientifically uninterested, but if they just knew more, they would use more science, right? As if there's not enough information out there in the internets that they could access. So for scientists, this information deficit model implies that if we could only communicate more or communicate better, like get out our bullhorns or like put science everywhere, that people would start using science in their everyday life. Just feel into your gut, see if that makes sense to you. Another extension of this doesn't just have to do with using science, but it also has to do with social conflict over science, like some of that pernicious polarization I was talking about a few minutes ago. So the assumptions of the information deficit model say ignorance is at the root of social conflict around science. So this implies that if people just knew more, we wouldn't have any conflict, right? Because the facts speak for themselves. Bear with me. Just a couple more things on this topic. This is a quote from Nancy Barron, who is kind of the foremost leader in trainings for science communication. She spearheaded a group called Compass. She said, scientists tend to think that if they could only communicate what they know to the public, then the issues would be resolved, as if solving problems is simply a matter of filling the empty heads of an uninformed public. Yeah, right. As a member of the public, this is offensive to me. And trust me, some of my best friends are scientists, so I have nothing against scientists. But it's good to sometimes lay out our assumptions to know where we have room to grow, right? Because in actuality, only a small amount of the variation in how people form opinions is based on the level of information that we have, right? Remember how we were talking about our values, our ideology, our affiliations, like our identities. Those are all, and we're seeing this more and more. And in fact, in the last few years, we're starting to hear this more in the mainstream, how people kind of select their sources of information based on what they believe and what they value, right? So all of this to say, fighting anti-science with more science just isn't going to work. And to use that old adage, it results in us seeing the anti-science problem as a nail because all we have is an informational hammer. We need more tools in our toolbox. And this is why people like me have jobs like the one I have, right? I work alongside scientists to kind of expand the reach of what we do and expand the connections that we make. So we know that we can't convince people with information alone. We need better tools. Well, what are some of those tools? One of those tools is community science or citizen science, which is a term that I'm going to use interchangeably. And what it means is basically we open up the scientific process to involve volunteers or community members in processes of identifying problems, in defining research agendas, in carrying out methods, and making meaning from the results. So basically, community science or citizen science goes from us and them to just us, right? These are projects that we're all working on together because we all care about them. Have any of you ever participated in any citizen science? Yes, nice. So things like Christmas bird count, bio blitzes, NASA Globe. In essence, like if you've ever done 23andMe and you shared your DNA with research, you're participating in science in a certain way. It's it's a little different than actively collecting data. But those are some examples of being involved in data collection, making observations. So the first half of this talk was about like the ethos for why this even matters at all, in my opinion, in my humble opinion. And the second half, which is what I'll share now, is some best practices for using these tools to create community around science, which is my small way of trying to make a difference through science and bridge some of these divides in our society that we are experiencing so profoundly right now. So yeah, like I said, we'll use some examples of best practices for building community with science. So best practice number 1, put the community scientist or citizen scientist experience at the center of the research design process from the very beginning, not as an afterthought. So you might imagine that kind of in the lab, a lot of people think about their methods and they write their grants and they say, these are the methods that we're going to use. This needs to be totally watertight because my peers are going to critique the hell out of this when it goes under the review process. And this needs to be totally watertight and we'll figure out how to involve people later. That'll be an afterthought. Well, in Tahoe Rain or Snow, which is one program that I am basically the person on, we did it the opposite way. We thought about the experience of being involved from the very beginning of the research design process. And that made all the difference for the success of the study. So Tahoe Rain or Snow involves volunteers making ground-based observations of winter weather. So basically we asked them during winter storms, is it raining, snowing, or mixed precipitation right now? Really simple, right? So let's try it out. Is it raining, snowing, or mixed precipitation right now? It's raining. Good. You guys all get an A. Okay, awesome. So for a place like Chautauqua in this region, like who cares? Like we get so much water, we don't know what to do with it, right? But in the arid West, like the really dry region where I live, and so much of the West where you've been hearing about drought and winter snowpacks and water rights controversy, estimating the amount of water that falls from the sky like matters a lot. It's like, life or death and people fighting, blowing up, dams on the way down to LA and stuff like that. So basically, satellites do a really bad job of estimating whether it's raining or snowing near the freezing point. So we're talking between 30 and 40 degrees Fahrenheit. So satellites, as they go over, send down radar. So this is NASA. And they send down radar and they're like, the satellites are like, oh, we think it's snowing, but it might actually be raining or the opposite. So this matters because we use those satellite observations to inform weather models and estimate how much water is actually falling. But an inch of rain is very different than an inch of snow, right? So we got to get it right. We got to improve those satellite observations. The only way we can do that is with ground-based observations. But the scientists can't be everywhere at once, right? We can't put out 200 scientists for a half an hour while a winter storm is going to pass over and the satellite's going to pass over at the same time. So that's why it's really helpful to have citizen scientists get involved. So the short story, to sum all that up, it's a complicated study and it requires a lot of observers over a big area of time. But simple, straightforward methods or the user experience was the thing that made all the difference in making this project successful. So I want you to imagine that you're going about your daily life and then you see this. Maybe it pops up in your social media feed, or maybe it pops up in your email. And you're like, Tahoe, rain or snow, that's interesting. It's like gray and there's like this rainbow umbrella. That's cute. Okay. Oh, scientists need my help. All I have to do is text the word winter to this number. I can do that. That's easy. It's already on my phone. Cool. So you text the word winter to that number and you get a text message that says, welcome to Tahoe, rain or snow. We train people in 3 short text messages. So it's like getting a PhD by Twitter, right? All of the training for this whole project appears in 3 short text messages, 1 each day for 3 days. And in one of those text messages, you get a link and it says, it's really, really easy to participate in this project. All you have to do is click this link, open the app. Okay, this is an app it's a web-based app, so you don't even have to download anything. You don't have to go to the app store and figure out, search, and is it this app or that app? Nope, it's just a link. It opens a web page in your browser, but it looks like an app and it behaves as an app, so it's really easy to use. So this is an app that, sidebar conversation, Desert Research Institute created with UC Davis and the League to Save Lake Tahoe, which is a local nonprofit. If you've ever been to Tahoe and you see the Keep Tahoe Blue stickers, it's the Keep Tahoe Blue people. So we all have different citizen science programs. We use this app. It's really fun. Back to Tahoe, rain or snow. Do you see how many possible clicks there are in this? 3 possible clicks. So participating in this huge study, all you have to do is 3 possible clicks, answer 1 question. Is it raining, snowing, or mixed precipitation right now? If you have to think about that question for more than 2 seconds, it's probably mixed precipitation, right? If it's rain, it's obvious. If it's snow, it's obvious. If you're not sure, it's mixed, okay? The app grabs your geotag. So your app grabs your location. It grabs the time. Boom, that's all you have to do, okay? So really, really easy. Not only is it easy to participate, but you don't even have to think about it after you sign up, because when a winter storm is rolling by, we'll send you little alerts like this that remind you to participate, because we're watching the storms for you. So we're watching the storms and we say, hey, this is a really good storm to tell us what's happening outside right now. So we might say something like, be on the lookout for sprinkles or snow pellets this evening or tomorrow if you haven't already had a storm brush by your area. Okay, thanks for keeping us updated through the Citizen Science Tahoe app. So we're doing the thinking for you. All you have to do is tell us what's going on where you are. This community, that you subscribe to when you sent the word winter to that number, also allows you to reply to my text messages. So sometimes I get questions or I get texts back that say, it's lightly snowing on the K to K trail. And I'm like, that's so cool. Did you submit your observation in the app? Just reminding people how the program works, because people's lives are busy and your minds are on lots of other things. So this is a really easy way to keep people engaged and kind of like quality assurance almost for the data. I can also troubleshoot problems with people in real time. Like somebody texts, hey, the app is no longer opening on my phone. What's going on? Well, why don't you uninstall and reinstall and try that? Oh, great, it worked. Yay, problem solved. And sometimes there's just like a lot of random banter, which is super fun because again, we're creating community with science, right? We're enabling that kind of ivory tower wall to be broken down. And I just have dialogues with lots of weather spotters or other weather nerds like me. So this text message alert system, we're the only ones doing this that we're aware of, right? We don't know anybody else who's doing science through text message alerts like this. Okay, that's all great. So we made this complicated study really simple for the users, but did it produce any data? Well, when we wrote the grant, this was the first, oh, thank you, Say. I know I'm all over the place. Thank you. So we wrote this grant to the Nevada NASA EPSCoR program. It's a seed grant. So we needed to get a little bit of pilot data to prove to NASA that this was worth funding. So we wrote it in 2019. We launched it in 2020. And we were like, if we get 200 observations, if we get 200, people clicking rain, snow, or mixed right now, that would be really good. Well, in the first winter, this was the winter of 2020, we had over 1,000 observations. So we got more than fivefold data than we thought we were aiming for. We had over 200 observers sign up, which was amazing, right? We almost doubled the first season's data in the second season, 2021. And NASA has funded us to expand this program, not just from the Reno Tahoe area, but to the whole Mountain West. So we can compare arid areas to wetter areas like the Cascades and go all the way to the coast. So we're going to be in places like Utah, Montana, Wyoming, Washington, Oregon, California, Colorado. We're really excited. So that's what we're gearing up for this fall and winter. But the results, did we get any cool results? Yes, we did. Remember how I said that the satellites are estimating the rain snow threshold, and they're usually drawing on other factors like temperature to be able to make that call. Is it rain or snow, right? Is it a 1 or a 0? Well, we determined that in arid areas like ours, that rain snow boundary tends to happen closer to 4.2 degrees Celsius or 38.5 degrees Fahrenheit than it does around 0. So we're not questioning the freezing point of water, but we are questioning when snow actually melts and turns to rain, and it has to do with humidity and a bunch of things that I'm not going to get into in this talk. But if we change this threshold, we could improve, we could correct almost 50% of those inaccuracies. This is a big deal for a dry place. So the bottom line is, in a very short amount of time, we designed this study with user experience in mind, and it has made all the difference. If you want to find out more, you can go to bit.ly/TRS news release. We published a paper on this this winter. You can read the news release, which is like not a scientific journal paper that's going to make your brain feel like scrambled eggs. It's like the plain English version. And then if you want to link through, we published it in an open access journal, so any of you can access it at any time. So that is Tahoe rain or snow. And that is the first case study. And it is really fun. Let's look at best practice number 2 with another citizen science project that we do. Best practice number 2, view community scientists or citizen scientists as stakeholders, value their opinions, and seek ways to connect and engage with them, okay? And the example that we're gonna use in this case is microplastic citizen science. Now, usually saying the word microplastics makes people get this little knot in their stomach. It's like scary, right? Microplastics, they're everywhere. We might even be breathing them in right now. Yeah. So they're the size of a pencil eraser or smaller. They can go down to like nano size, micron size or even nano size. And they are concerning for the environment. And we want to know if there are impacts on public health or, human health. So they're a concern. So many of the clothes we are wearing are synthetic, like what I'm wearing right now. The carpets and the upholstery that you're sitting on, probably synthetic. So those are microplastics when they break down. Okay, so they're in a lot of places. And as a group that, the Reno campus of the Desert Research Institute is 35 miles from Lake Tahoe. We do a lot of work in the lake. Lake Tahoe is a pristine alpine lake. It happens to be very high visibility, right? It happens to be a place that's high profile. And people care about it. But no one had looked for microplastics in Lake Tahoe before our team. So we were pretty sure that given the fact that microplastics are everywhere, that if we looked in Lake Tahoe, we were going to find them. And so understanding the impact on community members of these results and understanding how people might engage with the issue as stewards was really important before we even set out collecting data. So I give a huge amount of credit to my colleagues who were working on this, that they were open to learning about what community members thought about this issue and and what people were scared of, what people cared about, and what they were willing to do about it, right? And so don't tell them, but I set up a process where they were going to learn all about what community members cared about from the very beginning, so that when it came time to share the results, and when it came time to engage people in solutions about microplastics, their pump was already primed. They had already learned about what people cared about and what people thought, right? So we held focus groups, and we set up ways for the scientists to listen to people. Okay, so these are some focus groups with citizen scientists. So not only were they listening to community members, but they were listening to the people who were helping collect some citizen science data related to microplastics. I'll explain that in a second. And we heard all kinds of things. There are some people that even think that microplastics come from chemtrails. Okay, never mind. Chemtrails. Okay, so you know when you see a plane flying over the sky and you see that like jet stream, and it's just the plane exhaust with water condensing around it. Some people think that it's a conspiracy theory that like the government's trying to microchip our brains or something. So anyway, it's one conspiracy theory and blowing it into another thing. So thankfully, microplastics are not coming from chemtrails. Just for the record, microplastics come from us, and we're gonna all help solve them. So this is just a little stop motion to show you how highly visible this work was when we were doing the field work. So I'm a science communication specialist. I'm not a scientist, but it's easy to learn these field methods. And so I'm out with the team. And as you can see, this is Kings Beach in Lake Tahoe. If any of you have been to the area, this is a really visible place on the beach to be doing this work. And so people were coming up to us all the time. What are you doing? Looking for microplastics? Oh my gosh. And so we were talking to people and listening the whole time, which is great. So this was late April 2 years ago. People are out all year round, highly visible. What we asked the citizen scientists to do was collect stormwater runoff. So this is water that's running directly from the street into the lake, because this is one of the sources of unfiltered water and potential sources of microplastics in Lake Tahoe. Fun fact, wastewater that from the communities around the lake, around Lake Tahoe, is not pumped back into Lake Tahoe. It's pumped to a different watershed. So that's why we were trying to pinpoint other sources of microplastics into the lake. We found them. And remember how I said that having scientists prepared to talk to the community about this kind of sensitive and scary topic in their pristine mountain lake was going to be important? Well, the LA Times broke the story even before we had published it. One of my colleague, Monica Arienzo, gave a presentation at Tahoe Summit where there were, a bunch of senators and stuff. And they broke the story like months before we were thinking they were going to, but they were ready. The scientists were ready. And they gave great interviews with the journalists, and the journalists kept coming, and they haven't stopped because we have continued the work in the Las Vegas wash. We're looking at microplastics in snow. We're looking at, sources of microplastics and how they get into our waterways. And so the journalists were prepared, or excuse me, the scientists were prepared when the journalists came, and they can give confident interviews that are also compassionate and understanding. And so if we think back to this best practice, microplastic citizen science is a story all about how understanding community perceptions of your particular issue makes for, better science communication, but it ultimately made for a better lab culture. And our group is now really on board with liaising with community members at any point. And it's just part of what we do from the very beginning. So that's microplastics. We can all breathe easy now knowing that there are good people working on this important topic. Are you ready for best practice number 3? So best practice, you have a question? I want to answer that question when we're done, because I think it's going to it's a big question. I want to unpack that. So yeah, let's put a pin in that. So very good question. Best practice number 3, looking for ways to give back. So people are volunteering their time, their energy. I want to make sure that people's time and energy is recognized, right? As they help with our work. And so through different programs, we've looked for ways to give back, and Stories in the Snow is a really good example of that. Stories in the Snow involves taking pictures of snowflakes, with your smartphone and a macro lens. So I want you to imagine that you're in a 4th grade classroom and all of these kids have tablets and they've connected a macro lens, like this lens that blows up the image in the camera. And they're all running around learning how to use this macro lens so that they can take pictures of snowflakes when it starts snowing. This is what Stories in the Snow is. And then they take those pictures and they send them to us through that same app that I mentioned before, the Citizen Science Tahoe app. So we have thousands of pictures from people and the snowflakes that they have taken in their own backyards, which is really fun. And so Stories in the Snow now reaches 500 to 700 students per year. And this past year in COVID, we just did virtual visits, but we still got the materials to them through the mail. Thank you, mail system, right? And it's a great way to bring students into science who might not otherwise be interested, because we're using photography and we're using technology, and it's really cool. It creates a sense of wonder, a sense of curiosity about the environment. So this is one way of giving back. And now I'm going to explain just really briefly why scientists care about snow crystal pictures in the first place. So, pop quiz. What are the ingredients we need to form snow? Water. Yes. There's one more ingredient. Dust. Yes. We need an ice nucleation agent or particle, right? So it could be dust, it could be soot, it could be pollen, it could be another ice crystal. And that's because water vapor or super cold water droplets, whatever the form of our water is at that moment, needs something in its liquid form. It needs something to crystallize around. And so those are the ingredients that need to form snow. Great. But why are snow crystals shaped differently if it's all the same ingredient? That's because conditions of temperature and humidity are the key factors in determining snow crystal morphology. So here we have some stellar dendrites. We have some kind of crystal that's covered in grapple or super cold water droplets froze to the surface. We also have these cool rosette patterns on that other side. These are all photos that citizen scientists have submitted. The reason the program is called Stories in the Snow is because the shape of the snow crystal tells us something about what's happening in the storm that weather radar can't. So it's another way of, again, ground truthing what's going on. Our scientists care the most about the presence of grapple. So those ugly asymmetrical crystals in the middle, they care about that because there's a lot more water in a foot of snow like that than there is in that light fluffy stuff that you like to ski on. So that's kind of that's really what they're looking for. But there's all this other cool stuff that we get to learn along the way, right? And so coming back to temperature and humidity, this is a schematic by a scientist whose last name is Nikaya. And you can see on the x-axis, the horizontal axis, that we've got temperature. So it gets colder as we move in that direction. And we've got humidity, and it gets higher humidity as we go higher on the y-axis. And you can see that there are these correlations between different combinations of temperature and humidity and the shape of the snow crystal. So this is a great way to teach kids about the connection between what's going on in meteorology, like a big scale, and the properties of water, the chemical and physical properties of water. And it connects to national or next generation science standard, and it's all wonderful, happily ever after, right? So the scientists look at that. They look for the presence of grapple or rhyming, which is the super cold water droplets on the surface. They also make some correlations between the types of storms that come through, like an atmospheric river, cold pool storm, northeasterly flow. I can send the link to anybody who's interested. Do we have to stop? Okay, cool. I don't want to stop talking. Here are some pictures of kids doing the project. It's really fun. We also do some outreach at ski resorts. That's really fun. And happily ever after, we give back to people. So how about I stop now and we do questions?
Sure. Part of what we like is the opportunity for people to
Yes.
talk immediately to the speaker and back and forth. And we encourage you to do that. So after I give my boss a chance to say something, we'll pass the mic around to whoever has a question. So let me ask Bob first to come on up. This is the other Bob, Boss Bob.
First, I'd like to thank the Hurlbut Church for letting us be in here and have a venue to get out of the rain. No snow, just
No
rain.
snow, just rain.
And one thing though that you all need to appreciate is that it's costing us a little more to do science this year because we're not in a institution supported facility and we're having to do our own sound and audio visual. So there's a little basket out there. Pretend like you're in a church and you're giving a donation. The other thing I'd like to see, I'm an archivist now in my third career. And so in addition to this wonderful work going forward and looking at things today, we can also look at things in the past. And here at Chautauqua, they've been doing a newspaper since 1876. And that paper for a long time actually did the weather every day. So we can go back and look at the weather right here on this ground for a long time. It's the detail, say in 1921, there's details. And so I think part of citizen science we could do here is encouraging people to go back and collect that data and see what the trends have been. And we can do that. And it might not even, it won't be easy, but a lot of the daily's been digitized. So we might be able to figure out a way to do it. That doesn't mean we have to go to the archive center, but we can do some good science. And thank you for coming. Oh, the website is, we really have a sensible website now, www.ChautauquaScience.com. Can't be any easier. And when you go there, you'll see our program. We'll try to keep it up to date. And you'll see the new Gmail site where you can send us a request for a link to the Zoom talks. It turns out none of this is easy, so please be forgiving if it doesn't seem to be perfect. But Bob Spiritus is perfect.
No, not perfect, but I just double checked you. It is HT. That's the program is on ChautauquaScience.com. There's also the registration. If you want to register to get a Zoom link, that registration is sciencetalkschq@gmail.com. So if you prefer to stay out of the rain the next time, you can get on our Zoom list. So please, if you have a question, raise your hand. I'll come to you. Mary, you get the first.
Let's take the
first question.
microplastics question first. So you want to ask it again?
I wondered when you were talking about microplastics, that if the journalists breaking that story before the scientists were really prepared for it or didn't really want it to come out yet, caused alarm in the public before they were ready to deal with it.
So that's a really good question. So just for the record, in case what I said wasn't created the wrong impression, my colleague shared this with journalists, but what she shared was, we found microplastics in Lake Tahoe. And she knew she was sharing that with the journalist. The journalist didn't it wasn't like leaked or anything malicious. So the story, what was reported was microplastics were found in Lake Tahoe. And what are microplastics? That was what it reported on. But given the charge and the concern around this issue, and given that science is taking a long time to be able to answer the question, are microplastics harmful? It's that uncertainty that we don't know how to deal with that makes us uncomfortable. That's where the issue lies, right? It's not that the journalists did their job wrong. And it's not that saying, hey, we found microplastics in Lake Tahoe and we're still developing the methods to be able to tell if microplastics cause any harm or not. You know, that is going to take a while. And so it's just the fact that collectively uncertainty is hard and it's uncomfortable. And so we tend to, you know, the alarmist thinking comes in those spaces. And I think that for the most part, scientists are trying to be clear. And this is a conversation that we've had many times in my lab, is how can we talk to journalists in a way that isn't alarmist, but it also does, you know, underscore the importance of this issue for, you know, continuing to study it and for stewardship, right? Like those plastic straws that you're doing so good to give up, and the plastic bags that you're, you know, remembering to forego because you brought your reusable grocery bags, for example. So that is a very good question.
I forgot to add that we're trying to we're taping whenever we get permission from the speaker, taping the talks, and we're working on a way to get those added to our website. So that's a program in progress. Norman?
Thank you for your talk. In the news recently, people have been dying because of wet bulb conditions. That is high temperature, high humidity. They can't sweat. How do you get that across to people that they have to watch out for the conditions when they go for a hike?
That is a really, really, really important topic. So context for everyone. Hot days and heat waves aren't a new thing, but hot days and hot nights are getting hotter, and we're having less respite between heat waves, most likely due to climate change. And so this phenomenon has an impact on people who are vulnerable and people who maybe don't have air conditioning, or maybe who work outside in Phoenix because they're road crews and they don't have a way to take a break from the heat, or maybe they're farm workers, right? This is an area of study. How to communicate to folks who are vulnerable to take care of their health is a really big area of study. I actually have colleagues, I'm not a specialist in that particular area. I have colleagues who are working on that very question. Social scientists working with meteorologists and climatologists to create an understanding of what the risk factors are, and then create the right messaging around it. How many of you have heard there's a National Weather Service warning, there's a National Weather Service watch, and been confused about what the difference in all of those? Yeah. So National Weather Service and NOAA are aware of this. People who do other kinds of messaging around you know, weather related health risks are also aware of this, and they're working on it. And yeah, it's especially important obviously in summertime. So thank you for that question.
Hi, you're going to hate this one. I'm a pediatrician and work with other pediatricians, and I see a large number of children that are like the parents are refusing to vaccinate. Some of my partners will refuse to see those patients. So consequently, my practice was growing with more unvaccinated parents. So what do you do to engage them? Because no matter what amount of information you give them, it's like, I don't want it. And I see it rising in the vulnerable inner city African American population.
So I will also qualify my answer here by saying that this is not an area that I am a specialist in, but this is an area that I'm interested in. So as we, you know, as we have kind of moved through the last year and a half, this time together, I've been trying to keep an eye on it. And a few things have stood out to me in terms of best practices. One is to recognize that like I use the term anti-vaccine up here. That kind of creates a black and white, right? It's either a yes or a no for you. But in fact, public health folks have been using the term vaccine hesitancy. And I think that's really helpful, at least for me as a translational science person, to remember that this is a spectrum, not a black and white thing. And that there might be, like with the help of someone like you, conversations that could help ease people's fears. And I don't know if it's the right information. If, we know, for example, that people are taking cues during the pandemic more from their neighbors and friends than they are from experts in a lot of cases. Not everyone, obviously, but if there are ways to connect them with other people who are maybe have had doubts or questions, but then they decided to do the safe thing, do the right thing.
Okay, Larry.
Yeah, very related question. Anthony Fauci is highly regarded, well-respected, at least in some circles. And he has a limited venue, right? He's not doing science for the citizen kind of stuff.
Yeah.
From your perspective in communicating science, what might he do better, or is he doing about as well as he can?
I thank you for asking for my opinion and not the absolute truth. My opinion on Fauci in my opinion, Fauci is an excellent communicator, and he's been in the public sphere and the political sphere long enough to not alienate. I hear him choosing words that don't alienate people whose political beliefs align with questioning science. And I think that is really positive. And when I would love to know in 5 or 10 years, I would love to do like a content analysis of the decisions that went into the CDC's decision. Now I know that, he is from the national, he's with NIH and the CDC, but all these people are working together. I would love to do a content analysis on the decisions that went into the lifting of the mask mandates and understand what behavioral and social science went into that. Because I think that would be really interesting. But so something commendable about Fauci is that he is listening to social scientists. He's probably listening to political scientists as well to inform his communication. And I think that is really positive. So that is my opinion. It sounds like he's got his ears open to interdisciplinary types of feedback, types of data. And I think that is really positive.
Hi, Megan. Thank you so much. As an educator for close to my mouth. Okay, I got it. As an educator for 25 years, I taught high school, I taught AP Chem, organic chemistry, and kids come into my class not understanding why it's important. For me, the why was more important than the actual facts. And I always stress that. And a lot of elementary school teachers are very uncomfortable with science. I love the fact that you're educating kids and getting them engaged. Is there a program in the United States besides just kits that the teachers don't necessarily understand how to use to get the kids so that they're not fearful of science, even though their parents might be uncomfortable with it? Because I think that's how you get the next generation to feel comfortable with this information. Like for me, scientific literacy has always been very important.
Yeah. Yeah. So you're asking, is there a program that's bigger than a pocket here, a pocket
Right.
there? I have mostly seen, so to just explain the context of the problem, many people who are teaching elementary school are trained in kind of general topics. They don't have a specialty in science. And so teachers might not feel that confident talking about some of the big issues that students are seeing in the news or that their parents are talking about. And we don't want kids just to take the messaging from their parents and have that kind of imprint on them too early without having a balanced viewpoint, right? So if their parents have anti-science beliefs, can they also get something more factual in the classroom from early on? And so Carrie's asking, is there something like nationwide that works to address this problem? In my experience, no. Okay, so the next generation science standards are kind of what came after Common Core science. And they take science, teaching science from going from something 2-dimensional to 3-dimensional. So rather than this is what you have to know, it's this is what you have to learn how to do. So teach science practices as well as core ideas. Does that sum it up?
How do you take what, there's this massive amount of information and distill it down to what does a first grader understand?
Yeah.
And I can remember doing stuff when I was in elementary school, but I didn't know it had any relationship to biology or physics. And
Right.
how do you get them to be excited on the elementary school level? It's
Yeah.
not my age group. My age group is 16 and 17-year-olds. But I think it's the teacher who has these uncomfortable feelings. They don't know enough. Like inquiry is a very big thing now. And I've helped to write 2 books in inquiry.
Nice.
And people are uncomfortable not knowing what is the right answer. Well, there's not necessarily a right answer. And I hear the elementary school teachers when we have tri-district stuff not feeling comfortable with it.
Yeah. Yeah. It's big. And it's a paradigm shift to go from this is the right answer to what are the questions that stem from my observations of the phenomena in my world, in the world around me. It's a big question. And there are a lot of good people, at least in my, because I also don't work, I mostly don't work with K-12, but a lot of good people who are working on that problem, but it is taking something that is national and, you know, the standards and then translating it to each and every person with the unique needs of that classroom. And it's a big task. So I think there should be a national holiday dedicated to teachers. I think education is severely underfunded and we should all applaud the teachers in our lives, please. So, yes.
Hello.
Okay, yeah.
I'm not from around here, but my brother-in-law lives not too far away. And we were talking yesterday about Fauci, and he was saying Fauci flip-flops. Now, he's not of the same views as me on a lot of stuff, but he was saying, how can you trust a guy who changes his mind? So how do you handle the fact that science cannot be assured? It's only as good as the information that you've got at the time. And how do you explain to the public that science is not assured and it's only as good as the information you've got at the time, and things will change and you have to change policy based on the information that you've got, because that opens you up to the criticism that you don't know what you're doing. And I think the US is really struggling with that at the moment because it's such an underbelly that can be used all the time.
We are. The US is really struggling with that. We want answers, we want certainty, we want truth with a capital T. And it comes back to the same problem that we were just talking about, is how do we help people understand the nature of science? The nature of science is a collection of principles, one of which is that, you know, nothing can be proven, only disproven. We're always trying to operate at the bleeding edge of what we know and what we don't know, addressing uncertainty, hopefully just, you know, correcting our ignorance. But we do the best with the information that we have at the time. And how do we do that on a large scale? I mean, I would love to see more investment in education for science from, right? I don't know if that's not the silver bullet though, right? I don't know if I can answer that question. Yeah.
I'd like to follow up on the teachers' comments here. And probably a lot of you are in the same boat that I am, and that is I was born just before the end of World War II. My father was a Methodist minister. My mother was a elementary school teacher. A very typical kind of family who were important in the community in the Midwest. I happen to live mostly all over Illinois. Only later, much later, did I find out that only 5% of the children in the country at that time had 2 parents who were both college educated. We're just about back to those numbers at this point. And we've got to get serious about quietly addressing that issue. And I don't think it's as hard as you think. We have Head Start programs. We have banks like PNC down in Pittsburgh who totally focus on very young childhood education. And this could very easily be the most popular after-school activity around. And people who study children say children are at their maximum curiosity at age 3. So let's get on with it.
Agreed. Thank you.
And you're just the person I wanted to talk about. So I'll let you sit down first. But you brought up a point that I worked on for many, many years. I taught primary grades for 35 years. One of my big interests was science. And so my classroom first became a science classroom. We had experiments going on. We grew things, used the sun, had weather stations finally connected to, the Chicago weather stations and things like that. So we had lots of things going on, but my classroom wasn't going to make it, for the world. Eventually we got it, to my school district, and then of course, the communication to the junior high and high school was very important. So I started doing that back in the 80s because, what we're doing has to connect to what you need and what you see, further on. It was very successful. And as we're talking about things, I was going through the kind of citizen science things we just happened to happen because we started, taking down temperatures and writing things down and discovered that, we could go back decades with small businesses in the area that had simply been writing down the high temperatures and things like low temperatures so they could discover when their best sales happen and things like this. And, and it was just amazing how things worked. Unfortunately, I retired 17 years ago. It continued for a while, and it's been up and down and things like this. So unless you have, people continue to support it, which I've tried to do in my school district as well as my, my town where I live, in my neighborhood, we just have to continue doing those kinds of things. Science is all around us, whether you're watching for the space station to go over and other things, or whether you're watching, just the stars come up and go down and things like that. So we need to continue working. Yeah.
I'm going to answer your question. So I worked at NIH at the same time as Dr. Fauci was a little higher up on the chain, but he only works 14-hour days. So yeah, you might try to flog him and get him to work a little harder. But I'll let you do that. Let me also mention that next week we have the last of our climate science talks by Walker Todd. He's going to give us his perspective. We will have a talk by a CDC epidemiologist later on in the season on August 14th. Douglas Hamilton is going to talk about emerging infectious diseases and his perspective. So there are things that we're planning to do that will address some of the questions you've raised, but we invite you to come back, and we appreciate your coming, and we appreciate the questions, and we would like to especially appreciate Megan Collins. Thank you.
Thank you. Thank you. Thank you all.
So Bob, you have another word from our sponsor.
You get a science hat for this. Yes. This all reminded me that the most revolutionary thing that we can tell our children is that adults don't know everything. Schools don't know everything. And how do they live with the fear and the risk that there's nobody out there who knows everything? And if we as proto-scientists were to start telling them that, we'd probably have more anti-scientists around. So these are all really hard challenges, and we can learn what we can learn. And clearly, information itself isn't the answer. And I think us being involved is the answer. And so we're glad you're here, and we'll see you next week.
Thanks, Megan.